We are on the second video of the series of, hey, I could do that on my 84, how do I do it on the Nspire? Well, if you're going to do this on your 84, you definitely needed some special programs. So I have here a slope field, and notice it is y1 prime is equal to negative x times y1. And so we have it graphed, and I have this initial condition. And actually, I could even change this initial condition and see the whole family of values. Perhaps you want to see a simpler example, like how about x? And then maybe we'll have the initial condition start out at 0. There you go. So what does this look like? So what we see here is we see again the whole family of values, which is why it looks like it's repeating. And there are some differential equations we can actually solve and find the solution. And this one would be the 1/2 x squared plus a constant. Why is there plus a constant? This shows you why there's a plus a constant. Okay, so let's take a look at the 84 and what's the next thing that the people could do. So here's an 84. Got another program that I installed. This is the TI-Smart view for the 84. How did I get this program on there? I loaded a file, and this file was shared with the TI-Nspire Google group, and so I put it under my Smart view, and there was a file called Euler. So it looks like Euler, but it's pronounced Euler, Swiss, one of the files that I already installed it. So no thanks, I won't overwrite it. So that's what it looks like when you install it. And if we want to run a program, you go to Program, and we're going to run Euler. Let's see how this one works. It says, what's your function? Let's go with x. I said x minus y. So we'll go with x minus y. Because since it says and y is in alpha and 1. Whew, got it. Enter. And it says, what is the first x? So in other words, the initial condition. So we'll start with 0, and then it'll ask me what is my first y. And how about I'll say 1. Enter. And what's the delta? Fairly common one would be to do a 0.5. And so there's a 0.5. And there's the first xy. Let's press enter again. And so when x is 1, then the y will be 0.5. Press enter again. And then when the x is 1.5, the y is 0.75. So is this possible to do on the Nspire? Oh yes. Now, I might recommend doing a spreadsheet, which I have on my website, and perhaps I'll share that with you. So the website is covenantchristian.org/bird, and if you look under the TI-Nspire, then you'll see something called Euler, and it's essentially just a spreadsheet. But let's take a look at how we can do this and some built-in features. I like the spreadsheet a lot because it really teaches the student what it is they're doing, the process. But if we just wanted to check an answer or something like that, yes, there is a way to check an answer. So let's do the same slope field that we just did. Again, since it says y1 prime, then we should do the, let's see, it was x minus, and we should say y1. And what was our initial condition? How about we start with the 0 and the 1, and if we can go ahead and take a look at what that looks like. Either enter or arrow down again. So there it is. Oh, it's so nice to see a picture of it. Now, if you edit the parameters with this ... yes, you can tab over and press enter. Then it says how many iterations between the plot step. Tab, plot start, plot end, and here's an important thing, the step. Let's say the step is 0.5. And then Actually, go down one more. The field resolution and tab. Oh, here it was. It was at the beginning. The solution method. We want to use Euler's method. And so there it is. It's already set up. The default is Euler's method, which I think a lot of high school calculus teachers will be quite pleased with. And that's what it's been using to do the calculation that you saw on the page. And I'm going to press enter. And there it is. Not quite as many resolution, as high of a resolution, since instead of 0.1 we're doing 0.5. How could we see what these values are? I've got a couple of ways. One method. Let's try menu trace. If you look under menu trace, hey, there's the 0.5, and then here when x is 1, then we get a value of 0.5 for the y, and so forth on down the way. Isn't that lovely? Now perhaps you wanted a few more digits, because there are actually more precision that is capable. I just pressed enter when I was doing trace. Now I'm going to press escape. I will hover over this point and I will press the plus. So using my little touchpad and moving it to hover over that value, and I'm going to press plus, and it shows me more digits. Isn't that nice? That's a fun way to do the more decimal places. Let me show you another method. What happens if you do Control T? And just so you know, I'm not making stuff up. Let's look under menu, and how about the view? And show the table is Control T. That's what I want to do. Now I'll just press it right here. Hey, there's a table. And this table shows me what the value is, just like before when we were doing the trace. Oh, hey, there that is. When the x is 3, the y is 2.03125. You're like, hey, I thought it was a step of 0.5. How can I see a step of 0.5? Well, like anything on the Nspire, if you want to do it, you could probably find it under press menu. Under menu table. What do you want to do to the table? Well, you'd like to edit the table settings. And so let's change the step size to 0.5. Enter. There it is. And now we have a nice table of values. So those are a couple of options with Euler's method, and we'll talk more. Oh, something I really wanted to share with you is slope field forever. If you want to learn how to use slope fields on the Nspire, I highly recommend this file called Slope Fields Forever. It walks you through, gives you some step-by-step and a little hands-on tutorial, teaches the key things you need to know for the AP exam regarding slope fields, and gives you some nice little tips, important things to know. And oh yeah, here it is. Tells you about this little icon, about entering more initial conditions, and edit the parameters, etc. And again, it lets you test it out. Oh, it even has a nice little extension of how to use the DE solve if you have the TI-Nspire CAS. You can find this on the Google Group website, and it will become available sometime on timath.com.